Math Time with Miss Hartzell, Module 8, Lesson 9. I can partition circles and rectangles into equal parts and describe those parts as halves, thirds, or fourths. So, as you learned on Monday, we are learning about fractions this week. And we learned some terms that can help us to define how a shape is been divided into. We know that shapes can be divided into halves, thirds, or fourths. And obviously, shapes can be divided into more parts, but in second grade, we're just going to focus on halves, thirds, and fourths. So today we're going to have a big focus on circles, because when we divide a circle into fractional pieces, it can be a little tricky. So stay tuned for that information. And before you practice and learn how to take a circle and divide it into fractional pieces and answer questions about fractions, I want you to pause and think and remember some of the words that you learned yesterday. So do your best today and don't give up. You're amazing. Pause and think time. So try to remember what you learned about fractions yesterday. How would you describe the way that I separated the whole pizza? Did I separate this pizza into halves, thirds, or fourths? When you're finished thinking about the answer to this question, press play. Okay, so before we dive deeper into this target, I just want to go over how to take a circle and divide it into parts, because this can be tricky and I just want to give you some advice about it. So a little while ago, we learned about measurement and we were using the diameter of a quarter to help us measure. Now that information is going to help us when we are taking this circle today and we are going to divide it into parts. So if you remember, or you don't remember, no big deal. When you're taking a circle and you're dividing it into parts, you have to make sure that you are focused on the center of your circle. So you can either draw it or you can just try your best to imagine the center of the circle. Because if you try to take this circle and divide it into parts, and draw a line that doesn't go through the center, then you're not going to have equal parts, okay? This part does not equal the part that's over here, okay? So that is not going to be a good fraction to use. So using the center of the circle is going to help us in dividing our circle into parts. So if I want to take this circle and divide it into two parts, then I'm going to start at one end of my circle and I'm going to go through the center of the circle to the other side. Now I have two parts that are equal in size. And I did that by just making sure that the line that I drew went through the center of my circle. Now I have two parts. But what about if I want three parts? Because that kind of seemed similar to a diameter, which it was. When you go from one end straight through the center to the other end, you have split the object into two parts, and you also have labeled the diameter. But what if you want to take this circle and divide it into three equal parts? This gets a little trickier. So to do this work, you're going to start from on one end of the circle. And you're going to draw a line towards the center. And you're going to stop. Because if you continue drawing your line, you are not going to set yourself up for making three equal parts. You have to stop here. a line from one end of the circle to the center and stop. Then to make the other two parts, because remember, we want to try to take this circle and put it into 3 equal parts. We're going to start at the center, and we're going to draw a line, and then we're going to draw another line. Now the circle is divided into 3 equal parts. And doesn't this kind of look a little familiar? Peace signs. Peace signs are an example of a circle that's been divided into 3 equal parts. So try to remember that if you ever divide a circle into 3 parts. Like if you have a birthday and your mom asks you to cut the cake, and if there's only 3 of you, you got to remember, cut towards the center of the cake, and then one direction this way, and starting from the center, going in another direction. Then you will have 3 equal parts. Now let's try to take this circle and divide it into fourths. This will seem familiar to our diameter, but there will be more work to do. So again, we're going to focus on the center because we want to make sure our lines either cross through the center or they touch the center. So I'm going to start by taking the circle and splitting it into 2 halves. So starting from one end, I'm going to do my best to go through the center to the other side. Okay, so I've just made the diameter and I've just split it into 2 parts. But I want this circle to be split into 4 parts. So I'm going to draw another line, this time a horizontal line. And I'm going to draw it from one end straight through the center to the other end. Now I have 4 equal parts. So just, reminding you and showing you how circles are divided into fractional pieces, because working with a circle can be different than working with a triangle, a trapezoid, a rectangle, or a square. So I just wanted to give you that experience so that you are aware. The rest of our questions for today are going to focus on, well, what happens when part of your fraction is either shaded or missing? How can you represent that part? So stay tuned as we answer those questions. So now let's dig a little deeper into fractions. So now that we know how to take a shape, whether it's a circle or a rectangle, and we can divide it into equal parts to discuss fractions, let's talk about what happens when we either shade a part of the whole, or in the instance of this image and real life, when part of this whole is eaten. So the question says, what fraction of the cake was eaten? Well, to solve this problem, we need to look at the image and we need to imagine as if that missing piece were still there. How many pieces was this cake divided into? 4. It was divided into 4 pieces, and I know because I can see the lines and I can imagine that last piece being in there. Also, I notice that there are fractions that are on top of the other pieces that are still left over. These fractions can help me understand what part is missing. Fractions have some special qualities. This fraction here, 1/4, represents each part of the cake. This top number above that line, which is called a fraction bar, is called a numerator. So I'm going to say that again. The number that is above the line is called a numerator. This number represents the part of the denominator which is missing or left over. Depends on the question that you're being asked. Our question is asking us what part of the cake, what fraction of the cake was eaten. So we're talking about the missing part. And so far, we can see from our image that's only one piece that's missing. So that's why we're using the number 1. The number underneath the fraction bar is called the denominator. This number represents all of the divided parts, even the parts that are missing. The denominator is representing the whole. So if the whole was divided into 4 parts, then our denominator will be 4. If our whole is divided into 3 parts, then the denominator would be 3. And so on and so forth. In this case, the cake was divided into 4 parts. So our denominator will be the number 4. And to answer our question of what fraction of this cake was eaten, only one piece was eaten out of 4 pieces. So 1/4 of this cake was eaten. So to understand this a little further, let's talk about those other pieces. What fraction of the cake was left over? So now we've heard the words numerator and denominator, and maybe we kind of get it, but maybe we kind of don't. And that's okay. We're learning new things, and it's okay to be confused. Let's read our question again. It says, what fraction of the cake was left over? So that means what part of the cake was not eaten? So when the cake was whole, it was cut into 4 pieces. One person ate a piece of cake. And now we need to figure out the fraction of the cake that was left over. So how many pieces are still in this image, still left over to be eaten? 1, 2, 3. 3 pieces are still left out of the 4 pieces that the cake was cut. Remember, the numerator, is the part of the denominator which is either left over or missing. So right now our question says, well, what part of the cake was left over? And we counted. There were 3 pieces that nobody ate. The denominator is the number underneath the fraction bar, and that number represents all of the divided parts, whether we can see them or not. They represent the whole. The denominator represents the whole. So the whole was divided into 4 parts. So that number did not change. What changed was the numerator, because our question changed. It's asking what was left over, not what was eaten. So let's take a look at some different examples. Here are some more examples to help you understand. These examples are showing shaded fractions. And each fraction, again, is representing a part of the whole. In this first example, we can see that one part is shaded. But how many parts are there in all? How many parts was this whole divided into? 1, 2. 2 parts. So our fraction is representing what has been shaded. One part is shaded, and the circle was divided into 2 parts. Looking at the next example, right here. One part is shaded, but how many parts was the whole circle divided into? Well, for this example, 1/4, this circle was divided into 4 parts. One part is shaded, that's this part right here, but there were 4 parts divided. The whole was divided into 4 parts. Now let's take a look at the next example. Now the circle is divided into 3 parts. How many parts are shaded? Just 1. 1 part is shaded, and there were 3 parts of the whole. So that's why the fraction changed to 1/3. And in our last example, it's kind of like our cake example when we talked about what part was left over. 3 parts are shaded. 1, 2, 3. Oops, sorry. And how many parts made up the entire whole? 4. This circle was divided into 4 parts. So to represent a fraction that represents this circle is 3/4. So fractions can come in all shapes and sizes. We can look at fractions as circles, we can look at fractions in triangles, squares, and rectangles, and much more. The important thing to look for is to notice how many parts are shaded and how many parts are used to divide the whole. That is what's the most important about when you're looking for fractions. So in your daily practice and when you complete your exit ticket, you will be taking a look at wholes that have been divided into halves, thirds, and fourths. And today you're going to notice that some of those parts are shaded. And your questions are going to ask you, what parts are shaded? Maybe the question might even say, what fraction of this object is unshaded? So you have to carefully read your questions and carefully look at what parts have been shaded and what parts were unshaded. That's going to tell you the numerator. To figure out the denominator or the bottom number, all you have to do is count all of the parts that created that whole. Even the ones that are shaded or unshaded, everything counts for the denominator. So I hope that this video helped you and that you're ready to do some work with some fractions. You know the drill. Now it's time for you to practice looking for fractions of circles and rectangles or polygons today. So do your best today. Look for the important parts of the fraction, parts that are shaded, parts that are unshaded, and then most importantly, when you're looking for that denominator, you should be counting all of the parts because that's what the denominator represents. It represents the whole, but it represents the whole in the parts that it's been divided into. So do your best. Once you're finished practicing with some hints during the daily practice, then you will show what you know using your exit ticket. And try to do this without any help. But as you know, if you do need help, talk to your families or rewatch the video for any assistance. Do your best and have a great day.